Space is much larger than hundreds of light years across.
And in particular, this assumption is saying that you can go as far as you want and you never encounter an end to the galaxies.
Exactly. And everybody who studies cosmology sees that assumption, but the implications don't strike home. When it says spatially homogeneous, that means homogeneous in space, uniform composition throughout all space. That means there is no big empty space beyond all the galaxies. And that has important implications. This principle was extremely important, and yet it sort of sneaks in and not many people think about it. Like you were saying, John, the Copernican principle, or the cosmological principle, claims that the universe has no edge or center. And I've shown a picture of what I would call an island universe, or maybe an archipelago universe, where all the galaxies are in sort of a large sphere, and outside that there's some big empty space. People picture the Big Bang as starting in a large empty three-dimensional space from a little tiny thing that explodes out. And so the place where it explodes out from is a natural center. And beyond where the exploded stuff has reached is empty space. But that's the public's idea of the Big Bang, and that's not what the experts think about it. Here's a quote from Edward R. Harrison, a good book called Cosmology, the Science of the Universe. But he says in popular literature, the universe has a center and an edge. So that's how the public imagines it. But, he says, this is wrong. It has no center and edge. You might take that picture of an island universe and peel off the word Big Bang from it and call it Humphrey's crazy cosmology. But I think it's also the biblical cosmology. It's a bit hard to understand how the Big Bang experts actually look at their own theory. But in the experts' Big Bang, this is a good way to think about it. Let's say, pick a direction, and let's go infinitely fast and infinitely far in that direction. What the Big Bang assumption says is that we will never encounter a big empty space where there are no galaxies. Or even at the very beginning, we would never find an empty space with no matter and energy.
Even at the instant of the Big Bang,
exactly,
you could find no place where there wasn't matter.
Exactly.
And that is a crucial assumption,
right?
Of absolutely essential assumption behind the Big Bang.
And yet the experts don't explain this because it's very hard. But this way of picturing it, if you travel infinitely fast and infinitely far, even at the very beginning, you'll never find an edge of matter or an edge of energy. So if you can't find an edge, you can't draw a boundary around it and define a volume where the stuff is, and then you can't define a center to that volume. So it has no center either, even at the very beginning. Now, quick way of explaining that is that the Big Bang assumes that our space that we exist in expanded right along with the matter. Now that's still hard to understand, and unless we talk about an extra dimension, such as the video Starlight Time talks about, most people won't understand it. But the experts know this is hard for most people to understand, so they don't bother explaining it. But this is the crucial difference between my cosmology and the Big Bang. Why would the experts make such a hard thing to understand? Is it required by the facts of science? And the answer is no. It results from assuming the Copernican principle or the cosmological principle. This principle is arbitrary and evolutionary. And again, this book by Hawking and Ellis, in that same section, introduces it practically with this sentence: however, we are not able to make cosmological models without some admixture of ideology. Admixture means something inserted into, and ideology means a body of ideas that people assume are true without investigation. In other words, you can't just start from the observed facts about the cosmos and build a unique cosmological theory. You have to stick in some other ideas. Now, another article about this principle was written by Richard Gott in the British science journal Nature in 1993. And in this article, which was titled The Copernican Principle, he said that he started off by talking about Darwin, and he said Darwin showed that in terms of origin, we humans are not privileged above other species. We're not privileged in time. Other species were before us, and other species will be after us, and we're just the latest in a long sequence of living things. Then he says, well, the universe doesn't have very many special places, like a center or an edge. There are only a few special places. And he says in astronomy, this Copernican principle works because, why? You're likely to be in a non-special place. There's only a few special places, and if we got where we are by accident, then we are likely to be in a non-special place. Now, the problem that the theorists were trying to grapple with is that we do look like we're in a special place in the universe. The universe looks pretty much the same on all sides of us. So if we were at a center, then we would be at a special place. So they wanted a theory that would have no special places, where every place would look just like it is here.
Let's make sure everybody is following what you said. It is a fact that space, from our vantage point, looks more or less the same, regardless of what direction we point our telescopes. Is that true?
That's exactly right. And the microwave radiation that we get is very much the same from all directions.
And so there's two main possibilities. One is that we're near the center of the universe. That would, I mean, if we were near the center, things would tend to look the same in all directions.
Right.
The other possibility is that there is no center, and things look the same regardless of where you are. The prevailing viewpoint has chosen this second understanding, this second assumption, that we're not at a special place, we're not at the center, that every place looks essentially the same.
Yeah, and essentially they're saying we're going to assume and manufacture a theory in which there is no special place like a center. Right. And so then every place will look like every other place, and we won't have to face up to this uncomfortable idea that maybe we're in a special, very unlikely place.
Is there any way of testing which one of these possibilities is really true?
Yes, there's some exciting new evidence that we'll talk about.
But up until recently, there hasn't been a real good way of determining which position was correct.
Right. The answer is coming out that we are near a central location. But I wanted to point